Hey everyone, welcome to hok'stutoring. Hope you're having a great day. Today we are doing question 7 from chapter 13D. So static dynamics chapter, connected particles. Right, let's get into the question. This one shouldn't be too hard, but it is a slightly different kind of scenario that you normally get with connected particles. So I just want to make sure we cover that. Let's get into it. Question 7. Two masses of 10 kilograms and 5 kilograms are placed on smooth inclines of 30 degrees and 45. So smooth incline meaning no friction. Life is good. Right, and then it's placed back to back, so it just looks like this, right? The masses are connected by a light string over a smooth pulley at the top of the plane. Okay, part A, find acceleration. Part B, find tension. Very standard questions. Let's get into it. Okay, whenever you're doing these questions, you have to always label every kind of forces. Okay, so I'm going to extend these forces a little bit. So that we can draw every other force here. So there must be tension, obviously. Tension going up and down the plane, actually up and up the plane. And then you got your 10G. I'm going to extend the arrow so you can see what's happening. That's the weight force of the 10 kilograms object, and that's the weight force of your 5 kilograms object. Okay. Now you always draw an invisible triangle whenever you are encountering inclined planes so that you can find your horizontal force and your perpendicular force. In this case, we know angle is 30 degrees here, so that's the same angle, that green one is the same angle as this 30 degrees. So if you want to find the horizontal force using a little bit of trigonometry, it's just 10G sine of theta, so sine of 30 degrees, okay? So sine 30 degrees. Right, and then we do the same thing on the other one. So I'll just switch color, maybe blue. Draw your invisible triangle here as well. If you want to find this force right here, then it's just using this angle, which is the same as the 45 degrees, okay? So if you do that, you do the same thing. It's your magnitude of the hypotenuse multiplied by sine of the angle of the incline. So that is 5G. So I'll just write it down here. 5G sine 45 degrees. Okay, so that's your horizontal, that's your tension. We don't have friction at all, so like guys, you're done. Okay, you can label reaction force, but since there's no friction, you don't even need to find reaction force, because reaction force up here and reaction force up here for this other object, they will always balance out with the perpendicular force, okay? So that the object doesn't, fly up the air or down the ground, okay? Right, now that you've labeled everything, we can solve for acceleration and tension in the one go, okay? Let's have a go. Part A and B, we'll just do them together, really. You can do them together. Right, so we split, when you're doing connected particles, you split them apart, do them separately. Make two equations out of it. But before we set up the equations, we need to know the direction of motion first, right? That's always the first thing you need to do whenever you encounter these questions. What is the direction of my acceleration? Is it going down that way, or is it going down the other way, right? We need to determine that. So how would you do that? Well, that's why we found out these horizontal force. You just need to find which force is bigger. Is it the 10G sine 30 pulling both of them this way to the left, or is it the 5G sine 45 pulling them to the right? Okay, so 10G sine 30, we just do some quick maths. 10G sine 30 degrees. Well, sine 30 is half, so that would give us 5G. Going this way right here, going to the left, and then going to the right is 5G sine 45. Now, it's pretty clear here. Sine 45 is 1 on root 2, so you get 5G over root 2. 5G is definitely bigger than 5G root 2, so we can conclude that the acceleration is going to go down this way, okay? So that's where acceleration is going to go. So none of that, okay? So just rub that part out, and that's where acceleration is going to go. Okay, direction of motion down the inclined plane to the left. Now that you've sorted that out, we can now solve for the two equations. So equation number 1, looking at the 10 kilograms particle, we know going down is bigger than the going up. So that means it's 10G sine 30 minus tension. Okay, so 10G sine 30 must be bigger than tension. So 10G sine 30, we found that as 5G, just right here, just then, minus tension, which we don't know, so 5G minus tension, and then that is equals to 10A, okay? So mass times acceleration, acceleration is A, okay? Now equation number 2, looking at the 5 kilograms object, we know this time that tension must be bigger than 5G, because we know that both of them must be going to the left. So in that case, we have tension minus 5G sine 45, which is 5G on root 2, which found that over here, equals to mass, which is 5 times acceleration. They both have the same acceleration because it's a system of objects, system of pulley, okay? Okay, so you've got equation number 1, equation number 2, guys. Just solve for A, solve for T, do your simultaneous equation. We can just add these two equations together. The negative T and the positive T cancels out nicely, and what you end up with is 5g minus 5g over root 2 equals to 10 plus 5, so that is 15a. Then all you need to do is solve for acceleration. Put in decimal places. Your acceleration should be equals to 10.096 if I'm not mistaken, meters per second squared. Right, guys, that solves part A. Find the acceleration of the system. If you want to solve for part B, all you need to do is chuck in the 10.096 back into your equation. I'm going to chuck inside the first one. So that's 5g minus tension equals to 10 multiplied by 10.096, and then therefore tension must equals to 39.4 Newton. Okay, so very simple, guys. Hopefully you found this video useful for question 7, and if you did, please leave a like. Aside from that, thank you for watching, and I'll see you in the next video.